So in this video, we're going to learn a very important theorem. So let's learn about it. Angles opposite to equal sides of an isosceles triangle are equal. I repeat, angles opposite to equal sides of an isosceles triangle are equal. So what is the meaning of this? See, here I've taken a triangle ABC. What is an isosceles triangle? A triangle in which two sides are equal. So let us say AB is equal to AC. So whenever you have a triangle in which two sides are equal, then the angles opposite to these sides are also equal. So what is the angle opposite to side AB? Angle C. What is the angle opposite to AC? It is B. I repeat, which is the angle opposite to side AB? It is angle C. Which is the angle opposite to side AC? It is B. So what this theorem is saying is that these two angles are equal. That is, angles opposite to equal sides are also equal. So remember, whenever you have a triangle in which two sides are equal, then the angles opposite to these equal sides are also equal. So angle opposite to these equal sides are B and C. So angle B is equal to angle C. So this is what this theorem is saying. So now let's study how to prove this theorem. So we'll first of all begin with what is given to us. So what is given to us? An isosceles triangle ABC in which AB is equal to AC. So this over here is given to us. Next, what do we have to prove? Very important. So we have to prove that angle B is equal to angle C. To prove angle B is equal to angle C. So I'll just rub this off. So we have to prove that angle B is equal to angle C. So I repeat, what is given to us? An isosceles triangle in which AB is equal to AC. What do we have to prove? Angle B is equal to angle C. Now how do we prove this? In order to prove this, we have to do a construction. What is the construction we do? We draw an angle bisector from angle A. So what I'll do is, I'll draw an angle bisector from angle A. What is an angle bisector? It divides the angle in two equal parts. So it's going to divide this entire angle into equal parts. So this angle will be equal to this angle. Let's say it meets BC at D. So write down the construction. Given to prove. Next, write down the construction. So what is the construction? Draw the angle bisector of A, right? So draw the bisector of angle A and let it meet BC at point D. So this is the construction we have to do. So done with given to prove construction. Now let's begin with the proof. So see, what do we have to prove? We have to prove these two angles are equal. So how do I prove these two angles to be equal? Look for triangles which have these angles as their part. So which is a triangle which has angle B as its part? Triangle ABD. Which is a triangle which has angle C as its part? Triangle ADC. So if I can prove these two triangles to be congruent, my job will be done, right? So how do I prove these two triangles to be congruent? Simple. AB is equal to AC, this angle is equal to this angle, and AD is the common side. So side angle side, by SS criteria, the two triangles are congruent. As simple as that. So take these two triangles, that is in triangle ABD, so in triangle ABD and triangle ACD. What do we have? AB is equal to AC. What is the reason? This over here is given to us. So mention in bracket, given. Next, these two angles are equal. Why? By construction. So angle BAD, so angle BAD is equal to this angle over here, that is angle CAD. Why? Because AD is the angle bisector. So you can write over here, reason AD is the angle bisector. So these two angles are equal. Next, what do I know about AD? AD is the common side. That is, AD is part of both the triangles. So AD is equal to AD. What is the reason? Common side. So write in bracket, common side. That is, don't forget to write these reasons in the bracket. So what do we have in two triangles? S SAS. Two corresponding sides are equal and the included angle is also equal. Hence, by SAS criteria, the two triangles are congruent. So I can write over here, this implies, now triangle ABD is congruent to triangle ACD. See, AB is equal to AC and AD is equal to AD. Which is the criteria I've used? SAS. So mention in bracket SAS congruence criteria or SAS congruence rule, your choice. So by SAS criteria, these two triangles are congruent. The moment the two triangles are congruent, we can get the corresponding angles. So let's get the angle corresponding to B. How do I get it? Label this 1, 2, 3, 1, 2, 3. I want the angle corresponding to B. Look for B in your congruence statement. B is over here. B is the second letter. So second letter will correspond to the second letter. So what is second letter over here? B. So angle B is equal to second letter over here, angle C. So we have angle B is equal to angle C. What is the reason? CPCT, corresponding parts of congruent triangles. So angle B is equal to angle C, hence proved. So this is how you prove this theorem. So I repeat once again. See, I want to prove these two angles to be equal. So what do? Search for triangles which have these angles as their part. So triangle ABD has angle B, triangle ACD has angle C. So if I can show these two triangles to be congruent, my job will be done. How do I show these two triangles to be congruent? Begin with what is given to you. These two sides are equal. Next, these two angles are equal. And AD over here is a common side. So two sides and an included angle are equal. So by SAS criteria, the two triangles are congruent. When the two triangles are congruent, we get angle B is equal to angle C by CPCT. Hence proved, right? So this is how you prove this theorem. So this is very, very important. So whenever you come across a question in which you have a triangle in which two sides are given to you as equal, immediately mark the opposite angles as equal. I repeat, whenever you come across a question in which you're given a triangle in which two sides are equal, immediately mark the opposite angles to be equal. For example, if this is a figure given to me, I am given AB is equal to AC. So immediately, what is the angle opposite to AB? C. What is the angle opposite to AC? B. Immediately mark angle B and angle C as equal. So whenever you have a triangle in which two sides are equal, immediately mark the opposite angles as equal. Right? So this is what this theorem says. That is, angles opposite to equal sides of a triangle are equal.